Hello everyone. So the next concept is base flow separation. Okay, base flow separation is nothing but the method of separation of the flow from the main bottom line, from the complete baseline. Okay, that and this is mainly applicable in rivers or lakes where the water gets stored in the lakes. Okay, and so to understand this better, we have three methods. That is, one is the straight line method. Okay, second method two, method three. Okay, in this, what you are going to do is, see here again we are measuring the discharge versus time. Okay, so it is a hydrograph only. We are going to measure the discharge with respect to time. So this graph represents the amount of rainfall which is occurring at a given period of time. So obviously the rainfall would have a rising limb. It would reach certain peak, maximum peak, and then it would come back to the normal. That means it reaches a maximum point and then it start reducing. So this is the discharge of any given rainfall or the runoff, excess runoff. Okay, now we know that from the background of hydrographs. So this is point A is the start of the discharge. B is the point where it is taking a crest. That is B to C is called as a crest. P is the peak, highest rainfall, and D is the stop of the rainfall. All right. So in this first method, if you want to find how much is the you want to separate, that is base flow, AD, anything below AD, okay, it is the uh, base flow separation. We are separating the hydrograph from the base flow. Okay, so here in this method, the base flow separation line is obtained by joining the end points. That is the rising limb end A, rising limb A here, and the end point of the direct runoff, that is D. By the straight line, if you just connect these two lines, you'll separate the original discharge. See, whatever is above the AD, this is called the excess discharge, excess runoff. Okay, whatever below this is nothing but these, all the water will be stored in the lakes or ponds or rivers as it is. Okay, this is the excess rainfall. So if you want to find how much is the excess rainfall, you can connect the start point and the end point of the hydrograph. Okay, this is the first method. Second method is same thing. Again, you plot this discharge versus time. That is A, B, C, and D. Okay, same points. Okay, then if you draw the line, okay, that means in this what happens is the recession curve. Okay, that is point A is extended forward, point A is extended forward, point D is extended backward, like this. And from P there is another line which is extended. Wherever these three lines connect, they become the AED. Now AED becomes the base separation line. Okay, you have to just pull this forward, backward, and this should be connected at this point, that is at point E. Okay, so AED is called as the base separation line. So whatever is above this AED represents the excess discharge or excess runoff. All right. Okay. The next third method to find out the base flow separation is, again, draw the graphs A, B, C, and D. Okay, this is the peak point. Now, what we have to do is the recession limb of the hydro. This recession limb, that is a D, is extrapolated. Extrapolated means it is backward. It is pulled, drawn backward like this until it reaches point C. Okay, until it reaches point C. Again, once you connect C and F like this, F is called as the inflection point. Once you connect the C and F, a smooth curve is drawn at A and it is joined here at A. Okay. So in this method, it is adopted when the groundwater storage reaches a similarly fairly, that means reaches the stream fairly and rapidly. So this method is used. Okay. Again, whatever is above this AFD line becomes the excess runoff hydrograph. Okay. All right. So these are the three methods. So we know what is the hydrograph. Now we'll see what is a unit hydrograph. So unit hydrograph is nothing but it's a hydrograph of direct runoff which is resulting from 1 centimeter depth excess rainfall occurring uniformly over the basin and at a uniform rate for a specified duration. Okay, so in the unit hydrograph, it is nothing but it is defined as the hydrograph. It is defined as the hydrograph which will have only 1 centimeter depth. It will have only 1 centimeter depth, which is having 1 centimeter excess depth of rainfall over a uniform basin at a specified duration of time. So it is again in the name itself. Unit means 1 centimeter rainfall. Hydrograph is nothing but it is the discharge. That is unit discharge in a unit period of time. Okay. All right. So now, next is there are many assumptions of a unit hydrograph. Again, this might be asked in the exam. Like we have to explain what is a unit hydrograph and explain the assumptions of the unit hydrograph. So again, assumptions would be as such: the effective rainfall of a uniformly, the effective rainfall is uniformly distributed over the specified period of time. Whatever rainfall happens, it gets distributed throughout at a specified period of time. Then the base duration of the hydrograph or direct runoff due to an effective rainfall of a unit duration cannot be unit can be a constant. That means this base separation, separation will always be a constant, and the effective rainfall is uniformly distributed throughout the area. It is distributed throughout the area and a specific duration of the time. And the hydrograph of a runoff due to a given period of a rainfall for a drainage area shows all combined physical characteristics. So it has all the physical characteristics, that is it is the excess rainfall, it is the infiltration happening. It will all have all the physical characteristics as such. And the time distribution of the direct runoff is assumed independent of the antecedent precipitation. So the time duration is all independent. It is not dependent on any other factors. Okay. Now, where can be this unit hydrograph used? Now, this unit hydrograph, it is used to derive the flood hydrograph. Flood hydrograph is nothing but whenever there is excess rainfall. So that excess rainfall is converted into a flood hydrograph. Okay. And that means at every interval, for every hour, we can find out how much rainfall and how much runoff has occurred. That is the meaning of this. Then application, again the next application is it is used to derive the flood hydrograph resulting from a series of rainfall each of the same unit duration. Okay, so again it is used if they having a same if there are series of rainfall which have the same unit duration. That means at every 1 hour, if you want to find how much rainfall has happened, by this flood hydrograph we can find out. Okay, and it is used to derive again it is used to derive a unit hydrograph from any other duration. So if you have a rainfall data or the runoff hydrograph of say 8 hours, so from that 8 hours you can reduce it and make it to unit hydrograph. That is, unit hydrograph is you can find out 1 hour hydrograph. So 8 hour hydrograph can be converted into 1 hour hydrograph, or vice versa as such. Then it is also used to determine the flood forecast. So flood forecast also can be calculated by using this, and it can be used to determine the runoff from a storm of 1 unit duration. Again, unit duration is at a given period of time, that is 1 hour. Okay, again there are quite a few limitations. So limitations means if the catchment area is, if it is greater than this thing, unit hydrograph cannot be applied when the catchment area is greater than 5,000 kilometers square. And as it is, if it is less than 2 kilometers also, it cannot be used. And it cannot be used when there is a uh, snowfall. If the storm is in the form of a snow, again this cannot be applied. And unit hydrograph theory is not that accurate, because and the accuracy obtained would be, again obviously there will be an error that is of plus of minus 10%. Then large number of unit hydrographs are required to catch for the catchment, because the unit duration changes and the unit hydrograph also changes. So unit hydrograph as it is in all, it is the at every unit, that is at every hour you're going to calculate. So at times there will be some error in this, so and that's why it's not that accurate. So these are the limitations, and in this there is derivations of the unit hydrograph and all. So all these derivations or the theory is not that means they'll not ask you in the exam, they'll directly give you problems. All this theory you can see here, it is only for you all to understand. So understanding this is little tedious. So more than theory, we can use all of this in the problems. So as it is, they'll ask you problems, so you can solve the problems. The same method. See here, this is the theory, this is the concept behind solving the problems. So once you can solve the problem, this is of not that much importance. Okay, all this is the background. Unit hydrograph, how to derive the unit hydrograph. Okay, with this background, the same thing we'll be using in to solve the problems here. Okay, all right, so in the next concept we'll start with the problems. All right, that's all for today. Thank you.